All right, in this tutorial, we're going to go over how to identify linear functions. So we're going to step into the graphing realm of our algebra and look at how to graph a linear function in the entire unit. But to just start out, we're going to look and see what the definition of a linear function is, how you can determine if something is linear or nonlinear, and then we'll go on from there. So a linear function is a function with a graph that is simply just a straight line. Now, part of the phrasing linear, the first four words or the root word of this, is a line. Just think linear starts with L-I-N-E, so that type of function is going to be a straight line. If there are any type of curves, or if you see anything where it has like a sharp corner, like a V shape right here where it turns and has a corner, it's not all going in the same direction. Those are examples of non-linear functions. Curves, straight lines, or if you see things where they're disconnecting. We'll get into more what these type of graphs are going to be, but anything that looks like this, that's not a straight line, is not linear. So the only possibility is that it has to be a straight line. So when you have the function written in either the y equals or the f of x equals, this f right here just stands for function. It's the exact same thing as y equals. F of x and y will be used interchangeably, depending on what the variable is. Then there are going to be no exponents on the variable, or at least no visible exponents with the variable. Now, when you have something that is y equals 2x, there is an exponent above this x. It is an invisible 1. This is okay. This is a linear function. If you see something that looks like this, 4x squared, that squared automatically makes this a nonlinear function. It's actually going to be called a quadratic, and it will curve. It looks something like this, a U shape. But again, you don't really need to be familiar quite yet with how to identify those types of equations. Just being able to answer, is this linear or is this nonlinear? So the two examples we have right now, first one is a graph, where it's going into a whole bunch of waves and motions and changing directions, altitudes, going upwards, downwards, backwards, forwards. Because it's not a straight line, this is a nonlinear function. Plain and simple. It's more of an advanced, higher degree polynomial, and you'll be able to determine based on the number of curves and how many directions it's changing, yada, yada, yada. But for right now, just know that it's nonlinear. And this one right here, f of x equals 1/3 times x. You could have a coefficient that's not a whole number. It could be a fraction out in front, but the only thing we care about to determine if this is linear or nonlinear, if there are any exponents above this x, and right now there are not. So yes, this is a linear function. So the number in front, the coefficient, does not matter. It could be positive, negative, whole number, most complicated fraction you've ever seen in your entire life, but all you care about is that variable and whether there's an exponent attached to that or not.